Hi, future scientists. I am Adam. Join me in this adventure to explore what physical and chemical properties are, as well as the dynamic processes of physical and chemical changes. What are physical properties? Physical properties are traits we can observe or measure without changing the chemical composition of the substance itself. Some examples are color, copper sulfate pentahydrate versus sulfur. Texture, smooth polished glass versus rough sandpaper. Density, gold has a density of 19.3 grams per cubic centimeter, while helium has a very low density of about 0.0001785 gram per cubic centimeter at room temperature and pressure. Melting point. The melting point of ice is 0 degrees C, while lead has a melting point of about 327 degrees C. Boiling point. Water has a boiling point of 100 degrees C at sea level and standard atmospheric pressure. Liquid nitrogen boils at a very low temperature of about negative 195.8 degrees C at atmospheric pressure. Conductivity. Metals are good conductors while plastics are insulators. Malleability. Aluminum can be hammered into thin sheets. Ductility. Silver can be stretched into wires or crafted into jewelry. Solubility. Sugar dissolves in water to make sugar solution. What are physical changes? Physical changes occur when a substance undergoes a transformation that does not alter its chemical composition. For example, sublimation of dry ice. It is solid carbon dioxide before and gaseous carbon dioxide after. Slicing bread. It is a loaf of bread before and smaller pieces of bread after. These changes involve alterations in appearance or state of matter, but the substance itself remains the same chemically. What are chemical properties? Chemical properties are inherent traits of a substance that determines its ability to react with other substances. Some examples are flammability, the ability of a substance to burn in the presence of oxygen. Gasoline and paper are highly flammable. Reactivity. Sodium is highly reactive and reacts violently with water, while noble gases like helium are inert and do not react. Corrosion. The ability of a material to corrode caused by chemical reactions with its environment. Copper corrodes in the presence of water and oxygen to form the greenish substance called patina, as can be seen on the Statue of Liberty. Acidity and basicity. The ability of a substance to react with water and produce either acidic or basic solutions. Vinegar is acidic with a pH less than 7, and sodium hydroxide or NaOH is basic with a pH greater than 7. What are chemical changes? Chemical changes involve the formation of new substances with different chemical compositions or identities through chemical reactions. In the atomic scale, during a chemical reaction, the reactants break their old bonds and make new bonds as they become products. Some examples of chemical changes are corrosion. When iron reacts with oxygen and moisture in the air, it forms rust. This chemical reaction changes the composition of the iron, causing it to corrode and weaken over time. It is written as Fe2O3xH2O, which is a hydrated form of iron 3 oxide, where X is the number of water molecules. Combustion. When hydrocarbon fuels such as gasoline or natural gas burn in the presence of oxygen, they undergo combustion reactions to produce carbon dioxide, water, and heat. This chemical change releases energy and is used to power engines and generate heat. Fermentation. Fermentation of bread dough by yeast involves several chemical changes. including the breakdown of carbohydrates into simpler sugars, the conversion of sugars into ethanol and carbon dioxide, and the production of energy-rich molecules. The carbon dioxide produced during fermentation is what causes the dough to rise. The ethanol in the bread dough evaporates upon the baking of the bread. Baking. Baking causes ingredients to undergo irreversible chemical transformations, resulting in the creation of new substances with different properties, making it a chemical change. Challenge questions. 1. Isaac mixes vinegar, which is acetic acid, with baking soda, sodium bicarbonate, in a beaker. Is this a physical or chemical change, and why? The fizzing reaction between vinegar and baking soda is a chemical change. NaHCO3, which is baking soda, plus HC2H3O2, which is vinegar, gives NaC2H3O2, which is sodium acetate, plus H2O plus CO2. So the products are sodium acetate, water, and carbon dioxide. We can test for carbon dioxide by bringing a glowing splint into the beaker, and the fire will be put out. This is because carbon dioxide is heavier than air and will displace the air from the beaker, which means there will not be enough oxygen in the beaker to keep the flame going. 2. Is the melting of wax a physical or a chemical change, and why? The melting of wax is a physical change. It is a phase change from solid wax to liquid wax due to the application of heat. No new substances are formed. 3. Endo mixes iron filings with sulfur powder in a test tube. Is this a physical or chemical change? This is a physical change because no new substances are formed. The iron can be separated out from this mixture using a magnet. 4. Isaac heats the iron-sulfur mixture in the test tube until it turns into a reddish-brown substance. Is this transformation a physical or a chemical change, and why? This is a chemical change. Fe plus S gives FeS. Iron combines with sulfur to make iron-2 sulfide, which is a new compound. 5. Is boiling of water a physical or chemical change, and why? The boiling of water is a physical change since it is a phase change from liquid H2O to gaseous H2O. 6. What happens when yeast is added to hydrogen peroxide? Is this a physical or chemical change? It is a chemical change, since hydrogen peroxide decomposes to form water and oxygen. 2H2O2 gives 2H2O plus O2. The yeast speeds up the reaction by acting as a catalyst. A glowing splint would become a bigger flame in the oxygen. 7. Is burning a piece of paper a physical or chemical change, and why? Burning paper is a chemical change. It involves the combustion of cellulose fibers in the paper, leading to the formation of carbon dioxide, water vapor, and ash. 8. Is dissolving sugar in water a physical or chemical change, and why? Dissolving sugar in water is a physical change. The sugar molecules disperse in the water without undergoing a chemical reaction. The process can be reversed by evaporating the water. 9. Is mixing blue and yellow paints to make green paint a physical or chemical change, and why? It is a physical change. It involves a change in the physical appearance of the paints, but their chemical compositions remain unchanged. No new substances are formed. 10. When solid iodine is heated in a test tube, it turns into gaseous iodine. Is this a physical or chemical change, and why? It is a physical change since it is a phase change. This process is called sublimation, where a solid directly transitions into a gas without passing through the liquid phase. Since the iodine gas is trapped inside the test tube with a stopper, the iodine gas solidifies on the sides of the cool test tube. This is called deposition, where a gas transforms directly into a solid without passing through the liquid phase. There you have it. Understanding the distinctions between physical and chemical properties, as well as the processes of physical and chemical changes, unveils the fascinating world of matter and its transformations. Please subscribe, like, and share, and I will see you in another science video. Happy learning. Thank you.